Finding the perimeter of a triangle, trapezoid, or parallelogram in the coordinate plane. Find the perimeter of the triangle with these vertices. Give an exact answer, not a decimal approximation. Simplify your answer as much as possible. Okay, so for this problem, you might get a triangle, a trapezoid, or a parallelogram. Any of these is going to be the same process, but first we need to think about what does perimeter mean. When it says find the perimeter of one of these shapes, what it wants to know is the outside distances. So for example, if we were finding the perimeter of a square, okay, that means all the sides would be congruent. So let's say this side is 4 long, so this one has to be 4 long, so all of them are 4 units long. Okay, so the perimeter would be each of these side lengths added up. So it would be 4 plus 4 plus 4 plus 4. Okay, so this perimeter would be 16. Okay, so that's what we're doing. We're just adding up all the side lengths. But we don't have a nice thing like a square. We have a triangle, a trapezoid, or a parallelogram. Okay, so really all you're going to do is find the distance between these 2 points, the distance between these 2 points, and the distance between these 2 points, and add them all up. But just to help you visualize what's going on, I'm going to graph it here for you so we can see what's going on. Okay, so the first vertice, I'm going to call this A, is at 6, 2. If you like to graph to help you visualize, that's awesome. If you don't want to, that's fine as well. The next vertice I'm going to call B is at 1, 2. So here's going to be B. Okay, and C is at 6, negative 6. So that's the vertice C. So let me get my ruler out here to connect my dots to look at this triangle that they're asking me to find the perimeter of. Oops. Okay, so there's my triangle ABC that they're asking me to find the perimeter of. So what I'm trying to do now that I can see it is I want to find this distance here, I want to find this distance here, and I want to find this distance of this diagonal line, and then add them all together, and that will tell me the perimeter of my triangle. Now, because I've graphed it, these 2 sides are pretty easy to find. I can just count them. Okay, but it might not always be easy to count. So I'm going to show you what it would be like to use the distance formula for each one of these. Okay, so the distance formula, just as a reminder, is the distance is the square root of the differences in x values squared plus the differences in y values squared, all under the square root. Okay, so I'm going to first find the distance between points A and B using the distance formula. So I'm going to find the line segment AB. Okay, so I'm going to call, so let's do this. D equals the square root of x2, which is 1, minus x1, which is 6 squared, plus y2, which is 1, oh excuse me, y2, which is 2, minus y1, which is 2 squared. Okay, so this becomes 1 minus 6 is negative 5 squared, and 2 minus 2 is 0 squared, which is really just 0. So I have the square root of negative 5 squared, which is 25. So the distance between A and B is 5, and I can verify that by counting my squares here. 1, 2, 3, 4, 5. Boom. The distance between A and B is 5, indeed. Okay? So the next thing that I want to do is I'm actually, because I know what my triangle looks like, I'm going to find the distance between A and C next. So I'm going to come over here, and instead of doing A and B, I'm going to do A and C. Okay? So I'm going to use the same distance formula. I'm going to do x2, which is 6, minus x1, which is 6 squared, plus y2, which is negative 6, minus y1, which is 2 squared. Okay, and I'll just simplify here. So 6 minus 6 is 0 squared, and negative 6 minus 2 is negative 8 squared. So I have the square root of 64, which is 8. So I'm claiming that the distance between point A and C is 8. Let's verify. 1, 2, 3, 4, 5, 6, 7, 8. Indeed. Okay? So if you don't have graph paper, that's fine. You can just do this and trust these answers every time. Okay? So now, last but not least, I just have to find the distance between points B and C. Okay? So I need to find the distance between points B and C now. So I'm going to set it up the exact same way. So x2 is 6 minus x1, which is 1 squared, plus y2, which is negative 6, minus y1, which is 2 squared. And I just simplify. Now here I have 6 minus 1 squared, so that's 5 squared, and negative 6 minus 2, which is negative 8 squared. So here I have 25 plus 64. Okay, so let me just make sure that I'm not making mental math mistakes here. 64 plus 25 is 89. So now I have a square root of 89. But I'm going to go ahead and stop you right here because most of you will probably jump to doing this on your calculator. But we get this long, ugly decimal. And in the instructions, it says, not a decimal approximation. So when it wants an exact answer, it wants you to leave it in the square root form. Because this is an exact answer, because we wouldn't have to round as we would a decimal. Okay? So here's our exact answer, and that's the end of it. So the perimeter is going to be 5 plus 8 plus the square root of 89, because that's how long this one is. Okay? So the perimeter is going to be 5 plus 8 plus the square root of 89. Okay? And 5 plus 8 is 13 plus the square root of 89. Now, can I add these two numbers? I cannot, because one is under a square root and one is not. So this right here is going to be my final answer in exact form. Not decimal approximation. Exactly this is my final answer for the perimeter of this triangle.